We are now going to do some max-min word problems. These are really neat. Yep, I'm using the word neat, that they're going to use all the skills we've been doing this chapter and are actually something you would be thinking about in the real world. So the first one, we're going to make a rectangular dog pen. It's going to be on the side of a barn using materials you already have. So let's go ahead and draw the red barn. Barns are always red. Then we're going to draw the dog fence. So that's going to be 3 sides, okay? And it's a rectangle, so I know 2 of the sides are the same. Now I'm going to go back and read the question more. I have 60 meters of fencing, and I want to make the greatest area, or max area. We're also, in addition, going to find the max area. So you're going to be finding the dimensions and the maximum area. Be careful with these questions. There's a lot of time. There's multiple questions in them. So if I have my rectangle, 2 sides are the same, x and x. I've already used 2x of material, so I'm going to take that away, and I'll have 60 minus 2x would be that long side. I'm going to be doing area, so area is length times width, so you would have area equals your x times 60 minus 2x. Now you can see that's a second degree function, so you know, and you can see the minus in there, that it's going to be a function with a maximum. So you're going to go ahead and go to a graph screen, and then we're going to type in our function times 60 minus 2x, close those parentheses, graph the, oh, there's a little line. How sad. What we need to do is change our window. So you can change the window to anything you want. To make my life easy, I always go ahead and say, okay, it's 60 would be the longest the possible length could be. So I say 60 by 60. I know that's way too big, but it gets me what I need. And then I'm going to go over here and say, this is my x. The longest a dimension could be was 60. I would cut it in half. And I have a beautiful little quadratic there. So I'm going to hit menu, and I'm going to analyze the graph. I'm going to get the maximum. So I just bring this, oopsie daisy, bring the lower bound, bring the upper bound, try again here. So let's see. And we can see we have a maximum at 15,450. So you're going to go ahead and sketch that. You want to label how big your window was. Draw a sketch of the graph. Show that maximum. Okay, so that x was the length right here. So this is 15, this is 15, and then 2 times 15 would be 30. So 60 minus 30. So my dimensions are 15 by 30. These are meters. And then the max area would be 15 times 30 is 450 meters squared. Okay, now you are going to try one. It's the next one on the page. Here you go. So take a second, look through this one. I'll pause it for you. And for this one, you should have come up with 30 feet by 60 feet and a max area of 1,800 feet squared. So the next question we're going to look at is taking a flat piece of paper, cutting out the corners, and creating a 3-dimensional box. So we're now going to be working 3 dimensions, working volume. So what you want to picture with your piece of paper is that you're going to cut out a little square out of each corner, and then we would fold up the sides. So because it's a square, this is x and that's x. X and x, x and x, x and x, x and x. There we go. So the total length of the page right here was 6. If I cut off an x from here and an x from the top, this section that I will now have will be 6 minus 2x. Same thought process here. This whole length is 10. I'm cutting off the x there and the x there, and this dimension will be 10 minus 2x. Let's get a different color. This one right there. So volume is length times width times height. And we're going to say, okay, x times 6 minus 2x times 10 minus 2x. And now looking at that, you can see a third degree x times x times x. You have two negatives that make it a positive cubic. So you're expecting something to have one max and one min. So let's go ahead and graph that. Just going to clear that out. Okay. So we have, now we have the equal symbol. We're going to say x times 6 minus 2x times 10 minus 2x. And we're going to graph that. It says that it doesn't like it. I wonder why. Okay, so I just started a new fresh graph here, and there it is. We can't see the max or min, so again, we're going to want to change the values. So figuring that y value represents the volume, so it wouldn't be 6 and 10, so I'm just going to say 6 times 10 times 2, and that's definitely going to get me all the way up. And I'm going to say that this would be a max of 10 because that's the biggest the paper is. So now I have a gorgeous picture right there. I'm going to pop it right over here. So on my graph. So we have our great little cubic right here. And we can see, I'm just going to put down the dimensions that I used. Here's the max that we want to look for. So I'm just going to go ahead and get that by analyzing the graph with a maximum. And we have a maximum of the point 1.2137, comma 37.8353. So then we have to go back to the questions and see what we actually want to write down here. First, what is the maximum value of the box? Well, remember, we plugged in this function x times 6x minus 2 times 10 minus 2x. That's my y value. So that 37 right there is my max volume. So volume is going to be 37.835. And then the dimensions, you have the first one is your x value. So you're going to have 1.214. And then you're going to plug that in here, 1.214, and 10 minus 2 times 1.214. And those give you the dimensions of 3.572 and 7.572. So now there's a type of this one that you can try. There you go. It's just a different size piece of paper. You can pause that. And this one only wants to know the max volume to the nearest tenth. So you'll find that to be 67.6. Okay. The last type we're going to do today is going to be dealing with maximizing profit. Okay. So there's two things going on here. And yes, there's a lot more that goes into profit and sales, but we're going to keep it very simple and say, how many am I selling at what price? So you're going to set two things when you see this kind of equation. Okay, I have the amount. I'm going to start with 80,000 times how much I'm selling it for, and it's $1.60 right now. So then we're going to go through And we're going to look and say, okay, after their research, they found that they will lose 10,000 readers each time they increase the price 40 cents. So what we're really looking for, our X is now going to be a counter. So each time I'm going to lose 10,000 people. So one time would be 10,000, two times would be 20,000, and so on and so forth. And the times that I'm talking about is the amount of money that I'm charging. So the first time I'm charging 40 more cents. The second time would be 80 cents. So now I have my counter in there, and I've created a polynomial function again. So I'm going to go ahead, graph that. So I've gone ahead and graphed that one and changed my window. So you're going to come over and do a sketch of that. Nice little quadratic. We got 10, 160. Okay, so then just analyze this graph. Get the maximum. Boop, boop. And I get 2. And then 144,000. So, questions it wants to know. First, what price will maximize the income? So what we find out with the 2 means how many changes we need to make to get to that max profit of 144,000. So we would have $1.60 plus 0.4 times 2, so that's 80 cents. And $1.60, so we're going to have a total price of $2.40 will maximize profit. All right, have a great night.